Everyone loves pi. It's the number given by the circumference of a circle divided by its diameter. It has an infinite number of digits arranged in a never-repeating pattern, but usually we approximate it with 3.14. It features in movies and books. It even has its own special day. Pi Day is on March the 14th. And, best of all for mathematicians, pi appears throughout mathematics. The normal distribution, Cauchy's integral formula, the Gauss-Bonnet theorem, Stirling's approximation, the reduced Planck constant. But let's stop. Did you notice something? It's not just pi that appears, it is 2 pi. For thousands of years, we have been looking at the wrong number. So says Bob Pallas at the University of Utah. He published an article called Pi is Wrong, where he explains why we should have been looking at 2 pi rather than pi. I should say at this point, there is nothing wrong in the value of pi. We haven't suddenly discovered that it's 5.14 or something similar. The point is that it is the wrong number to choose when associating a number to a circle. Pallas proposed that we denote 2 pi with a double pi symbol. But that looks a bit odd, so instead let's use tau. Thus the normal distribution changes to, Gauss-Bonnet becomes, and so on. Using tau as good notation for 2 pi was proposed by Michael Hartle in his Tau Manifesto. He points out that if we want to associate a number to a circle, the most natural definition is circumference over radius, which gives tau, rather than circumference over diameter, which gives pi. This is natural because a circle is defined as the collection of points that are a common distance, the radius, from a centre. We can't define a circle using the diameter, since there exist shapes which have a constant diameter but which aren't circles. For example, look at the 50p coin in Britain. The width is constant around the coin, but the coin is not circular. As soon as we define a circle, we can define tau. To define pi, we need to first define the diameter as twice the radius. In other words, we can define tau before pi. Thus, tau is more natural. You may be wondering, what's the big deal anyway? So, tau is more natural, and we don't have to write an extra 2 in lots of formulae. Wow, big deal. Hardly worth all the fuss of articles, manifestos, and videos. Well, tau begins to show its magical powers when we measure angles. Mathematicians don't measure angles using degrees, instead we use radians. There are 360 degrees in a circle. Similarly, there are 2 pi radians in a circle. So, in a quarter of a circle, there are 1/4 times 2 pi radians. That is pi over 2 radians. In other words, if we use pi as the constant associated to a circle, then a quarter of a circle corresponds to half the circle constant. A quarter corresponds to a half. That's just crazy. What if we take 3/4 of a circle? Here, 3/4 of a circle corresponds to 3/2 of pi. That's crazy too. How much of a circle does 1/3 pi radians correspond to? Well, 1/3 pi radians actually corresponds to 1/6 of a circle. Definitely crazy. Now, let's see what happens when we use tau. What is 1/4 of a circle when using tau? Well, it's 1/4 tau radians. Easy. What is 3/4 of a circle? It's 3/4 tau radians. Couldn't be easier. What does 1/6 tau radians correspond to? It corresponds to 1/6 of a circle. Okay, surprise quiz. What is 7/23 of a circle in terms of tau radians? Yes, that's right, it's 7/23 of tau. Seriously, can this be any easier? Okay, you might be saying, what about the area of a circle? It is pi r squared. That doesn't contain a 2 pi. True, here pi appears to be travelling unaccompanied by 2. However, consider the classic proof. The area is calculated as 1/2 times circumference times radius, i.e. 1/2 times 2 pi r times r, which is pi r squared, because the 2's cancel. In other words, there was a 2 there, but it cancelled with something else. Alternatively, if we use calculus, then at some point we integrate 2 pi r with respect to r to get 1/2 times 2 times pi r squared, i.e. again 2's cancel to give pi r squared. The tau version of the area of a circle is 1/2 tau r squared. Okay, this uses more symbols, but the half reminds us to take half the circumference, or that we are integrating r. So even here, tau is providing a service for us. It helps us remember proofs. I could go on with other examples, such as working with sines and cosines, and why tau makes Euler's formula so much better, which is amazing if you think about it. Euler's formula, one of the best formulae in mathematics, can be made better. Will tau replace pi? Well, not soon. Nobody likes change, and it would require a lot of textbook rewriting. On the other hand, tau is more natural than pi and brings simplicity and elegance. No extra 2's and no absurdities such as 1/4 of a circle gives 1/2 of a number. So tau has beauty. The great mathematician Hardy said, Beauty is the first test. There is no permanent place in this world for ugly mathematics. I guess Pi's days are numbered. Tau is here to stay. Since Pi Day is March 14th and Tau is approximately 6.28, it is natural to have 28th of June as Tau Day. You can read the manifesto and join the Tau Day celebrations at Hartle's Tau webpage, tauday.com. My name is Kevin Houston. You can find my webpage and blog at www.kevinhouston.net. Thanks for watching.